So, today we're going to talk about basically an introduction to building a Debian email server. And we're going to do it with quite a few packages. This is actually a very complex project and a complex topic, so we're actually going to take our time and work through this one slide at a time at first. And through the intro, we're going to do this kind of in two parts, I think. Maybe an introduction video, which will be this one, and then probably a demonstration video, which will be the part 2, and then maybe a bonus content video for anything that gets left out or any extra little packages or details I want to throw in there. Maybe I'll throw some metrics collection techniques and things like that in a bonus content video for you guys. But this is going to try to be an all-encompassing kind of project, so you'll get to see the ins and outs of how to actually do this fairly thoroughly. I'm going to try to be as comprehensive as I possibly can. But this is a lot of material to cover, so I'm going to try to move through it quickly. And I'm going to try to only touch on topics that are of concern to getting this thing up and running. So extra stuff like how exactly some of these packages really work, such as Graylist and Spam Assassin, you might have to pull up Google for that. I'll try to give brief explanations and demonstrate their configurations, but actually going into great detail, I'm not going to have a lot of time to do that just because of the sheer quantity of packages and the amount of setup that's going to go into this. So basically this video demonstration slash introduction here is going to be how to install and configure an email server using Postfix, Dovecot, Spam Assassin, Graylist, and ClamAV. And it's all going to be fueled by Debian 8 Jessie and is nearly free of cost. And the word nearly is important there because it's optionally free, right? So all the packages that we're going to be installing with this are going to be free and open source packages, and they're all going to be in the default Debian repository. So you don't even need to enable any of the proprietary repositories to get this done. The non-free repository, so to speak. You can just use the default stock Debian packages that are in the Debian repositories that you get when you install the operating system for the first time. And all those packages, of course, are free and open source. You can use them at will. So from that perspective, it is absolutely free. However, in order to make your server talk to the outside world, there are a few optional steps that you'll need to consider, and they do have some monetary investment to them. So I'll cover that on the next slide, but that is why we say it is nearly free and not totally free. So now we're going to talk about some prerequisites. These are the optional prerequisites that I mentioned in the previous slide. So these are the things that will make it nearly free. And I want to stress that these are optional, and it's important to note that. So without these, you can actually build a fully functional email server that will send and receive emails. That's not really a problem. The issue is that if you want to send an email to, say, Outlook.com or Gmail.com, a user from that system would end up receiving either your message as junk mail or not receiving it at all, not receiving your message at all, and then you get a bounce message back from Outlook. Outlook is notorious for that. They actually would not allow my email to go through at all at first, and I would constantly get bounces. So this is not comprehensive to allowing that to happen. There are additional steps, such as investigating the blacklists and things of that nature, which we'll touch on a little bit later. But these are necessary to get yourself off of those blacklists. Without these steps done, chances are you're not going to get off those blacklists, or if you do get off the blacklist, you'll be right back on. So let's go through these one by one. The first thing you're going to require is a static IP address from your ISP. These usually run in addition to your normal monthly cable bill or monthly internet bill, $20 a month, US dollars per month. Now, It's important to note that if you're running cable internet, so like through Comcast, typically a static IP address is not available to residential customers. In order to get static IP addresses, you'll have to sign up for business class internet. The good news is that $20 a month is generally good for 5 static IP addresses from Comcast. 5 usable IP addresses anyway. And so you actually get quite a bit for your money there. However, you pay a little bit more for your bandwidth tier than you would on residential cable. Now, I use a fiber internet, and they actually allow me to get a static IP address on my residential connection, but it's still $20 a month, and it's only a single IP address. I'm not using more than one, so to me it doesn't really matter, but it is less for the money. So keep that in mind. $20 a month is part of your monetary investment if you want this to be a production server kind of thing. Also, you're going to require a domain name. A domain name is like something.com, outlook.com, bing.com, google.com. Those are examples of domain names. And most email addresses, and I say most, but really it's all email addresses generally end with at something.com. So at outlook.com, at gmail.com. That's how the email gets routed. It's sort of part of the directions of who to send it to. And so without that, you're obviously going to have some difficulty sending and receiving email externally. These usually run about $10 US dollars per year, and they can be obtained from sites like GoDaddy or domain.com. Now, you might see some information about premium domain names. That is not necessary. What that means is somebody squatting on a domain name and trying to sell it or something along those lines. Generally, if you come up with something unique, original, whatever, you can sign up and get a really, really cheap one. Mine, I think, actually cost me like $8.99 per year. The next thing you might want to consider, and this one is absolutely the most optional of these optional prerequisites, because you can send and receive email even over encrypted communications without this particular requirement. But what you're going to want to get is a valid SSL certificate from a trusted certificate authority. And that's going to be important because when your users connect to your email server from their email client, so say Kmail or Outlook or Evolution or Thunderbird or whatever email client they happen to be using, if they try to connect over an encrypted protocol, then what's going to happen is they're going to get a certificate error message, and it's going to say something along the lines of, "This is an untrusted certificate. Do you want to create an exception for the certificate?" That means exactly 2 things for you. One, you lose out on man-in-the-middle checking, because that's the exact error that you get when there's a man-in-the-middle. If you're allowing an exception for the certificate, then man-in-the-middle checking is kind of lost in a sort of way. Now, granted, if the certificate is different for the man-in-the-middle when they attack, you'll get that error again. But it tends to be lost on your users because they're used to allowing your certificate at that point. Generally, they don't have to allow it every time, just once. So the other negative thing about that is it just looks bad, and it's more annoying and inconvenient for your users. So there are ways to get these for free, actually. There's a service called Let's Encrypt that is new, and it's from the EFF, the Electronic Frontier Foundation, and they are big on protecting people's privacy and defending all that kind of stuff. So they have actually created a certificate authority called Let's Encrypt that will allow you to download and get a valid certificate from them. However, they are a newer authority, so not a lot of systems will trust their certificates yet. I'm betting. So you could do what I do and use one from startssl.com. I do hear, though, that the last person I recommended go there was not able to get a certificate because they weren't apparently accepting new people for their free certificates. But they do have paid-for certificates that run about $50 to $60, and you can renew it every, I think, 2 years. but generally you're looking at anywhere from free to about a $400 US dollar investment, and that's usually renewed either annually, biannually, triannually, stuff like that. You know, it depends on what you sign up for. So you kind of got to shop that one to figure out what your actual investment is. But this one is definitely the least necessary. The most necessary, I would say, would be probably these two. Without these two, you're not doing anything, especially this one. That's the big one. The last thing you'll probably want to look into is a reverse lookup record in your ISP's DNS server. So what is a reverse lookup record? To understand what a reverse lookup record is, we have to know what a regular lookup record is. So the way a DNS server typically works is you type an or not an IP address, but an actual domain name into your web browser, say google.com. And your computer doesn't know what or where google.com is. It requires a little bit of help. And it gets that help from a DNS server because your computer is only going to talk in IP addresses. So the DNS server actually resolves the the domain name, and it turns it into an IP address for your system. So when you type google.com into your web browser, you send out a request to a DNS server saying, hey, where is this? And the DNS server sends you a response back saying, oh, it's at this IP address. And then now you know the address and you can get the site. This is really convenient for us because it makes it so that we don't have to memorize numbers. We can just memorize domain names, which are far easier to remember. But on the other hand, the computer can still talk without having us, demanding us to know all this crazy stuff. Most of the time this happens in the background and you're pretty unaware of it. But when you're setting up an email server, it's important that you have a reverse lookup record. Why is that? Well, first of all, a reverse lookup record is exactly the opposite of a regular lookup record, as you might have guessed. So what a reverse lookup record does is you submit an IP address and the DNS server will return back the domain. And this is good for verifying that the IP address is actually associated with that particular domain. It kind of guarantees validity in a way, I guess. So the good news is this is actually completely free, and your ISP should work with you and get this done, especially if you're a business class user. Now, I'm actually a residential user, and my ISP was more than happy to help me out. They were perfectly fine with it. So basically what you want to do is you want to call your ISP up and you want to tell them, look, I have this domain, this domain name, and I have this IP address, and I just need you to create a reverse lookup record that makes this domain name and this IP address point to one another. And so once that occurs, you won't get any, or you'll be less prone to getting bounce messages and being added to spam lists. So these are the required prerequisites, and you can see that the list is rather short, actually. So the only two things that are absolutely required to get this done are a Debian 8 Jessie disk image, or ISO. And if you don't know what an ISO is, Google that and consider learning about that before attempting this project. Because this project is a lot more advanced than, you should know what an ISO is before trying to do this. And the other thing you're going to need is either a hardware or a virtual machine to install said ISO on. Now, I am going to assume that you have these things already. I am not going to go through a demonstration on how to install Debian in this particular video or in any of the videos in relation to this email. I did do an email or a video demonstration on installation of Debian, but it was for 7. But the process is basically the same. If you want, you can reference that video. But Generally, it's pretty straightforward, and if you can't install the operating system, then this might be a little bit much for you. These are the prerequisites that I expect you to kind of know, knowledge-based prerequisites. This is what you should sort of understand in order to undertake this project and have the greatest chance of success, I guess I should say. So, if you don't know these things, that's fine. You can still watch this video and potentially succeed in building a server at the end of it if you follow my steps pretty strictly. Then you'll be relatively successful at the end. You should come out with a working server. However, I would advise against putting it into production, because without a good understanding of these things and security concepts and that sort of stuff and all that extra knowledge you should probably know on how to maintain a Linux server, you're either going to end up with a server that's not secure or a server that you can't maintain, and that's not good for production. So either be good enough to manage your server or have somebody at your disposal who is. So let's go through these. Basic understanding of the Linux file structure. So in Linux, you should know where things are laid out, where config files are generally kept, where libraries are kept, where your binaries are kept, what those things are, and you know, general Linux file structure stuff. If you don't know where things are, how can you possibly hope to troubleshoot and maintain them? So fortunately, there's a whole lot of help out there for that, specifically for Debian and Red Hat. And since this video focuses on Debian, a Debian installation, I would highly advise that you look into Debian's side of doing things. That's not to say that you can't do this on a Red Hat system. You very well could. I haven't personally tried it, but I'm sure you could. You just have to interpret some of the steps in order to make it work. This video pertains strictly and explicitly to Debian, though. I will not make any side notes about how to do this on Red Hat or any other Linux distribution. I can't even guarantee functionality on Ubuntu, although I'm pretty sure it'll work. So the next one, basic understanding of the Linux command line. So I want to note that despite during this video demonstration, you're going to see a GUI, or a graphical user interface, on the system that I'll be doing this demonstration on. That is because I don't feel like spinning up a bunch of virtual machines so that I can have different machines for the clients and the servers. I just want to make a quick demonstration so you guys can see, yes, this works, how it works, that sort of thing. I'm not looking to do some big fancy 10 different systems in order to make a perfect server that I'm going to destroy at the end of the video. That doesn't make sense. So I want to make it perfectly clear that my production version of this server does not have any form of graphical interface. It is command line only. It was set up in the command line, it is maintained in the command line, and it lives in the command line. Why do I do this? Less resources on my server, because I use all virtual machines for my servers, so less resources, that's always a plus, and it minimizes your attack surface against vulnerabilities. So it basically makes it harder for your server to be hacked because there's less software on it to be exploited. And that's something you should always do when you're hardening your system, is make sure that it has just what it needs to do its job and absolutely nothing more. This is especially true with servers, and even extra especially true with critical infrastructure servers like domain controllers or email servers. So Linux command line skills are a big plus here. You're not going to get very far without them. So Google and research that, or just watch my video and you'll probably learn a little bit about Linux command line skills. Because while the system we're going to be configuring will have a GUI, I'm basically going to bring up a terminal and configure everything using the terminal. We will not be using the GUI for really anything other than the demonstration at the end where I bring up a Linux email client like Evolution and try to connect up to it. Good troubleshooting skills. I should think this would be obvious, and I should think why, would be obvious. If something goes bad in the video and you can't, you miss a step or you can't figure out where you messed up, being able to troubleshoot that is good. I'll try to offer you guys support if you ask in the comments. but this is a very complex procedure, and it's very hard to trace down where you messed up, especially when I'm trying to do it in, the comments without actual access to your system. And I don't want access to your systems. Don't try to give me that. So, good troubleshooting skills. You need that. And that's sort of, that's a by the person thing. You either can or you can't. You can learn it, but a lot of that takes a lot of time and effort and energy in order to sort of go through and figure out. Familiarity with the operating system that you're working with is also a big positive. Familiarity with common computer terminology. Know the difference between the desktop GUI and the command line interface. Know what shortcuts are. Know what links are. Know what, shortcuts and links are basically the same thing. Know what a binary is, know what a library is, that sort of stuff. I kind of expect you to know it. I'll give brief descriptions of these things, but I'm not going to delve into them very, very much throughout the course of the video, simply because I don't have time. I mean, it's going to be a long video. Know what file and folder permissions and ownership mean. That is very, very important. To have the correct ownership. It's a security thing, and it's also just plain good habits to maintain the permissions and ownership on files to make sure that people who don't have or shouldn't have permission don't have permission. Make sure only people who require permission have permission. And by people, I mean actual user accounts and service accounts. Basically, an account on the system should have a required list of permissions, and it should not exceed that list that is required to do its job. And understanding what that is and what those permissions are and how to use the permission system in order to modify that stuff is important. In Linux, the hint that I'm going to give you is look into chmod and chown. Those are the two commands. Chmod for permissions, chown for ownership. Understanding basic networking terminology, such as what is an IP address, what is a subnet mask, what is a packet, what is a port, what is a protocol. That sort of thing is kind of important to know, especially when you're working with something that uses several different ports and protocols, such as an email server. Understanding of SSH, this is going to be very important for remote administration, and SCP is also a good idea for remote administration. SSH is secure shell. It'll allow you to make a remote terminal connection to another computer, and SCP is secure copy, which basically allows you to do a copy operation of files, of a file or list of files from one computer to another remote computer over secure shell. Knowing how to use those two commands can be a lifesaver when you're remotely administrating a system. Here are some packages we're going to be using in order to configure this system. So the list is as follows: phpMyAdmin. That'll be for administrating the SQL server. So we'll get an easy way to do that, and it will be less necessary for you to utilize it, but we're going to install it anyway on a just in case. PostfixAdmin. PostfixAdmin will be responsible for allowing you to create your mailboxes and also set up things like email forwarding and set passwords, etc., etc. Apache 2 is a web server, and it will be used to host these guys. Dovecot is your LDA, or local distribution agent, and it will be responsible for delivering email to your local clients. Postfix is your MTA, or mail transfer agent. It will be responsible for communicating your email to outside and even internal systems. It's generally referred to as the Port 25 or SMTP protocol, is what it will be mainly doing. Spam Assassin will be the first of your spam filter systems. It basically is a spam scanner. Graylist is a package that is used for spam filtering as well, and it basically filters spam in an interesting way. Basically what happens is a message gets sent to your email server, Graylist checks it to see if it's on the list of known senders. If it is not, it delays the message until a second attempt is made to send it, because most email servers that are legitimate will queue up messages that fail to send. It causes a slight delay, but only in the very first message that a sender sends, and it's very negligible. But it does waste resources for spammers who queue up messages, because they're trying to bombard people with messages. Making them resend them is obviously a thorn in their side. So while it's not necessarily the most effective tool against them, it definitely helps in that it wastes their resources and makes things more annoying for them. ClamAV is an antivirus scanner, and it will be used to protect your system from viruses. Pretty basic. Mailgraph is an optional package. You definitely don't need to install it in order to be secure. It is designed to get metrics. It will show you things like how many bounces you have, how many emails are successfully delivered, but it's a broad spectrum view. It's not like Big Brother. You can't actually read the contents of the email or see who sent how many emails, but just how many emails on your server overall were bounces, how many made it through, how many had viruses, that sort of thing. And MySQL is your database backend. And then, of course, all dependencies and supporting software, because this list is very, very basic and is just the overall list of software that we're going to use. There are tons and tons and tons of libraries and other applications that are going to be in support of these guys. This is just kind of a broad spectrum, a broad picture. So this is an overview of how your email server is going to actually function. There was a flowchart online that I found that was sort of similar to what you see here. Basically, I used it sort of as a skeleton to kind of figure out what I wanted to do with my own. It comes from a tutorial on how to do something very similar to this, but mine is for Debian 8 and theirs was for Debian, I think 7, maybe even 6. And they used Nginx and not Apache and did some other things differently than I'm going to do. So if you see that graph or that flowchart on the internet somewhere, I thought about posting a link to it just for full disclosure, but I don't want people trying to mix the tutorials, because you may end up with a broken system if you do that. So I think I'm going to leave it out. It's not, this particular flowchart's not a direct plagiarism, because I did make it from scratch, but it just kind of follows the same logic. And it does that because the logic is really very straightforward. I mean, it's kind of similar. But basically, the way it works is you have an email that comes in from the internet, and it's going to come to your postfix mail transfer agent. From here, postfix mail transfer agent is going to send it over to Graylist. Graylist is going to do its thing, scan it for spam the way I explained in a previous slide, and then it's going to bounce it back. Then Postfix is going to hand it over to Spam Assassin, at which point Spam Assassin is going to do its thing, scan it for spam, and then bounce it back. Then it's going to repeat the process for ClaimAV, where it will be scanned for viruses, and then it will bounce it back. And from there, it will be delivered to Dovecot, or Dovecot, and at this point it will be stored in your mailboxes. Alright, so now an email is waiting in the mailbox for the user. So then the user is going to send a request over to Dovecot here, and they're going to say, I want my email. And Dovecot's going to take their credentials and it's going to send it to the authentication, and the authentication is going to look in SQL here. And it's going to say, I want the username and password. Let's see if they authenticate. SQL will reply. If the authentication checks out, the authentication will bounce back and say, yes, we're good. At which point, the mail will be pulled and sent over IMAP, port 143 or 993, if you are smart, to the client. The client, of course, being the client computer, so Kmail, Outlook, Evolution, whatever the user is using. All right, so there's a little bit more to this, though, because there's one more simple thing that the user can use apart from Kmail, Outlook, Evolution, and that is a web client. So what is a web client? A web client is sort of like OWA if you've ever used Outlook Web Access if you work for a company, or like Outlook.com or Gmail. They all have web clients. So it's a client that you access in a web browser. Well, you can have access to that too. The one that I choose is Rainloop. However, there is Squirrel Mail, there is Roundcube, and I think the other one's called Alligator Mail, but I'm not positive on that one. Anyway, you have a lot of options for that, so you can get a webmail client to make this a fully 100% functional email server. You can still access your email over a web client. How does that work? You send your HTTPS request to your web server. It gives you your Rainloop website. Your Rainloop website acts as your mail client and sends a request up to this guy saying, I want my email, just the same as your local client over here would do. And then this process is exactly the same. The authentication should occur, and then it will send the email back over your IMAP ports, and then they will be displayed to the client in their web browser. So that's how that works. Okay, so now we're going to take a look at how a client will send an email to either an internal address or an outbound external address such as Outlook.com. So let's say the user, using one of their clients here, keys up an email address and clicks send. And let's say the user has addressed it to Outlook.com. So a user Bob at Outlook.com. So Bob at Outlook.com's email will send up here to Postfix, at which point Postfix will authenticate that the user who is sending the email is one that is allowed to be sending the email. They will send their authentication request over here. SQL will reply with the appropriate information to authenticate the user. If authentication is good, then the authentication will bounce back here, indicating that it is good, at which point Postfix will send the email out to the internet. Now let's say the email was addressed to a user on the local system, at which point you'll get a detour here. It will go back down here to Dovecot and get stored in the email boxes, just like a normal incoming email would. So basically right here you have sort of like an OR, where this can go either or, down or up and out. And that's the flow of an outbound email. Now, you can also send email from your web client. How does that work? The user will log into the HTTPS website, connect up to their Rainloop client. They will then send, pull up their email interface, type out their recipient address, type out the email address, and click send. And when they do, it will simply send it straight through the client and on, up, and out. And it will follow the exact same path at that point. Okay, so now we're going to look at it from an administration perspective. And this is pretty simple, ironically. So what will happen is the user on their computer here will log into the website on the Apache 2 web server, and they'll be presented with one of two sites depending on the address they type in. They'll either go up here to Postfix admin, or they'll go down here to PHP myadmin. So 99.9% of the time you're going to be working with Postfix admin, almost exclusively. So what is Postfix admin responsible for? Well, Postfix admin uses the MySQL data connection, and it also makes and edits mailboxes and credentials. So it's basically responsible for the management of your email server from from an admin perspective, essentially. What is PHP My Admin for? That is basically your direct SQL manager. So you're going to manage your raw tables with PHP My Admin, and generally you will not need to work with this. Almost never. Okay, so we've gone through a lot of information here, but let's put it all together. What do you actually get? What's the goal at the end of this? So what you get is a functional, secure email server. Secure transactions over TLS, a web front end via rain loops, squirrel mail, etc., whichever. Easy administration via postfix admin, antivirus and spam protection, optionally metrics, and a nice secure interface for users to change their passwords and their email forwarding settings. And this one right here is especially important because after setting this server up, I did a lot of Googling on the internet to see if there was a way for users to easily change their passwords. And a lot of people answered no, and there totally is. It's very, very easy. It just is going to require some configuration changes in order to meet my standards for security. And I will show you guys completely how to do this in the tutorial. But basically it's going to rely on this guy right here, postfix admin. Postfix admin will do this for you. And there is a configuration you can do that so that you can utilize here so that it is safe and secure. I will show you guys what I consider the proper method to make that work to be. So with all that said, the end goal here is happiness. Happiness that you have an awesome email server that is completely free and made out of Debian. So with that, I think I'm going to conclude part 1 of the video, which is the slideshow and all that. And in the next video, we'll move on to part 2, which will be the demonstration portion, where you'll actually get to see the configuration take place, learn how to do it, hopefully be successful in building your own system, and the world will be more joyous because we'll have more email choices out there. Thank you guys for watching, and good luck in the next video. Hope to see you there.